A health inspector doesn't test water. Let me say that again because it's important. A health inspector doesn't test water. A health inspector tests compliance. He walks onto a property with a checklist, a form that lists the approved components of a private water system under the state health code, and he checks whether each component is present. Sealed well casing? Check. Sanitary well cap? Check. Approved pressure tank? Check. Backflow preventer? Check. If every box is checked, the water system passes. If a box is unchecked, the system fails. The inspector never puts the water in his mouth. He never sends it to a lab. He measures the system, not the substance. This is how a spring that produced the cleanest water in Pendleton County, West Virginia, water that tested below detection limits for every contaminant the EPA measures, was condemned by a county health inspector who never tested the water. The spring was on the Harmon Farm outside of Franklin, West Virginia. 200 acres of cattle and hay on the side of North Fork Mountain at an elevation of 3,200 feet. In the Allegheny Highlands, where the rock is Devonian sandstone and the water that filters through it emerges cold, clear, and mineral balanced in a way that municipal treatment plants spend millions trying to replicate. The spring had been providing water to the Harmon family since 1891. 110 years of continuous service without a single reported illness, a single failed water test, or a single day without flow. Everett Harmon's great-grandfather, Jasper, had developed the spring in 1891 by excavating the discharge point on the mountainside, building a collection basin from hand-laid sandstone, and piping the water by gravity through hollowed chestnut logs to the farmhouse 400 feet below. The chestnut logs had been replaced by galvanized pipe in 1936. The galvanized was replaced by polyethylene in 1978. The collection basin, Jasper's original sandstone box, had been rebuilt once, in 1952, by Everett's father, Willis, who'd replaced the mortar joints and added a concrete cap to keep surface water and debris out of the spring box. The cap had a screened overflow and a lockable access hatch. The spring box was, by any practical assessment, a well-designed, well-maintained water source enclosure, but it wasn't a well. And in 2001, the West Virginia Health Code required a well. The health inspector's name was Dennis Rex Road. He was 39 years old. He'd been inspecting private water systems in Pendleton County for 7 years, and he arrived at the Harmon Farm on a Tuesday morning in March to conduct a routine inspection prompted by a property transfer. Everett's son, Nathan, was buying the farm from Everett as part of a generational transfer, and the county required a water system inspection as a condition of the property's sale. Dennis walked to the spring box. He looked at it. He opened his checklist. "Mr. Harmon, this is a spring, not a well." "It's been a spring since 1891. The current health code requires private water systems to utilize a drilled well with a sealed casing, a sanitary well cap, and a pitless adapter. Springs are not an approved source under the current code." The spring predates the code. The code applies to all property transfers, regardless of the system's age. When the property changes ownership, the water system must meet current code. Your spring doesn't meet current code because it's not a well, so the water doesn't matter. The water quality is not part of this inspection. The inspection evaluates system compliance, not water quality. You're condemning my water system without testing the water. I'm citing a non-compliant system. The code requires a well. You have a spring. The remedy is to drill a well, connect the house to the well, and abandon the spring as a domestic water source. Everett looked at the spring box, the sandstone walls his great-grandfather had laid in 1891, the concrete cap his father had poured in 1952, the screened overflow, the lockable hatch. He looked at the water flowing through the overflow, clear, cold, the temperature a constant 52 degrees year-round, the flow rate a steady 2 gallons per minute that had never varied in 110 years of measurement. He looked at the inspector who was checking boxes on a form that measured pipes and caps and casings, but not the thing that came out of them. How much does a well cost? A drilled well in this area typically runs 200 to 400 feet deep. At $12 per foot, plus the casing, pump, and pressure tank, you're looking at $6,000 to $10,000. $10,000 to replace a water source that's been providing clean water for 110 years, because your checklist doesn't have a box for springs. The code is the code, Mr. Harmon. Stay with me, because what Everett did next, and what the water test showed, is why the health code lost an argument with a mountain spring that had been winning arguments since 1891. Let me tell you about the filtration system, because the spring on the Harmon farm didn't just produce clean water by accident. It produced clean water by design. A design that Jasper Harmon understood in 1891 and that the health code in 2001 didn't recognize because the design predated the code by 70 years. The spring emerged from a sandstone outcrop at 3,200 feet elevation on North Fork Mountain. The water originated as rainfall on the mountain's ridgeline, 3,800 feet. 600 feet above the spring discharge. The rain percolated downward through the mountain's caprock, a layer of resistant Tuscarora sandstone, into the underlying Devonian sandstone, which was fractured and porous enough to transmit water, but dense enough to filter it. The filtration path was 600 vertical feet through sandstone, 600 feet of natural rock filtration. The water traveled from the ridge to the spring through a labyrinth of fractures, pore spaces, and bedding planes in the sandstone, each crack and opening acting as a filter element, trapping sediment, absorbing dissolved organic compounds, and providing residence time for the natural die-off of any biological contaminants that might have entered at the surface. The residence time, the time it took for water to travel from the ridge to the spring, was approximately 18 months. Everett knew this because his father had conducted a dye trace in 1968, poured fluorescent dye into a sinkhole on the ridge, and waited for it to appear at the spring. The dye appeared 18 months later, a faint green tinge in the spring water that confirmed the flow path and the transit time. 18 months of residence time. In water treatment engineering, residence time is the primary factor in pathogen reduction. Bacteria like E. coli survive in groundwater for approximately 60 to 90 days. Viruses survive 90 to 180 days. Protozoa, like Giardia, survive 30 to 60 days. At 18 months of residence time, 540 days, every biological pathogen that entered the system at the ridge was dead before it reached the spring. The mountain killed them with time and filtration. No chlorine, no UV, no chemicals, just 600 feet of rock and 18 months of underground travel. If you're enjoying this story, consider subscribing to The Average Farmer. We share stories like this every week. But the filtration wasn't just biological. The sandstone also removed chemical contaminants, dissolved metals, agricultural chemicals, and organic compounds through adsorption. Sandstone is composed of quartz grains, cemented with iron oxides and clay minerals. The iron oxides adsorb dissolved arsenic, lead, and other heavy metals from the water as it passes. The clay minerals adsorb organic compounds. The quartz grains provide surface area for the adsorption reactions. 600 feet of this natural treatment produces water that is, by measurable standards, as clean or cleaner than the output of a modern municipal treatment plant. Jasper Harmon didn't know the chemistry. He didn't know about adsorption or residence time or pathogen die-off curves. He knew that the spring water was clear, cold, tasteless, and that nobody who drank it got sick. He knew that the spring had been flowing from the same sandstone outcrop for as long as anyone on the mountain could remember. And he knew that a spring emerging from deep rock on a high, uninhabited ridge with no agriculture, no septic systems, and no human activity above it was about as protected a water source as nature could provide. The health code didn't know any of this. The health code knew wells. Wells had casings. Casings could be inspected. Springs had open rock discharges that couldn't be inspected the way casings could. The code required what could be inspected and rejected what couldn't, regardless of which one produced better water. Everett decided to test the water, not because the inspector required it. The inspector didn't test water, because Everett wanted the data. If the county was going to condemn his spring based on a checklist, Everett was going to test the spring against the checklist's own standards and prove that the spring the code rejected was producing water the code couldn't match. Everything was about to come down to numbers. But Everett had one thing the health code didn't. 110 years of a mountain doing the filtration that the code assumes only a drilled well can do. Everett collected water samples from the spring. 3 samples on 3 consecutive days, in sterile containers, following EPA sampling protocols that he'd learned from the county extension agent. He drove the samples to the West Virginia Department of Health Laboratory in Charleston, a state-certified analytical lab that tested for the full EPA primary drinking water standard. 87 contaminants, including bacteria, viruses, nitrates, heavy metals, volatile organic compounds, and disinfection byproducts. The results came back in 3 weeks. Total coliform bacteria absent. The EPA standard allows 0 total coliform per 100 milliliters. The Harmon spring had 0, not below detection limit. Absent. No coliform bacteria of any kind in any of the 3 samples. E. coli, absent, 0 per 100 milliliters. The most common indicator of fecal contamination was completely absent. The 18-month residence time had eliminated every possible source. Nitrate, 0.8 milligrams per liter. The EPA maximum contaminant level is 10 milligrams per liter. The Harmon spring was at 8% of the maximum, lower than most municipal water supplies, which typically run 2 to 5 milligrams per liter from agricultural runoff in the source water. Lead, less than 0.001 milligrams per liter. The EPA action level is 0.015 milligrams per liter. The spring water contained lead at less than 7% of the action level, effectively 0. Most municipal systems struggle with lead at the tap because the water picks up lead from the distribution pipes. The Harmon Springs polyethylene pipe added no lead. Arsenic, less than 0.001 milligrams per liter, below detection. The sandstone's iron oxide minerals were absorbing any dissolved arsenic before it reached the spring. Volatile organic compounds, all below detection limits. No pesticides, no herbicides, no industrial solvents, no fuel hydrocarbons. The ridge above the spring was uninhabited forest. No agriculture, no roads, no development. There was nothing on the surface to contaminate the water, and 600 feet of rock would have filtered it out, even if there were. Total dissolved solids, 142 milligrams per liter. The EPA secondary standard, aesthetic, not health, is 500 milligrams per liter. The spring water was at 28%, low TDS, which meant a clean, crisp taste with no mineral heaviness. pH, 7.2. Neutral, perfectly balanced. Most groundwater in West Virginia runs acidic, pH 5.5 to 6.5, because the rock is acidic. The Harmon Springs sandstone path included a section of limestone that buffered the pH to near neutral. Natural pH adjustment, no chemicals added. Everett laid the lab report on his kitchen table and read it twice. Every parameter was within the EPA primary drinking water standard. Every parameter was below, often far below, the maximum contaminant level. The spring water was cleaner than the EPA required for any public water system in America. Then he called the Franklin Municipal Water System and requested a copy of their most recent annual water quality report. The Consumer Confidence Report that every public water system is required to publish. He compared the two reports line by line. That moment changed everything about the argument with the health code, and the comparison between the spring and the city water would never let the inspector forget what the checklist had missed. The Franklin Municipal Water Report showed total coliform, 0, achieved by continuous chlorination, at 1.2 milligrams per liter, free chlorine. Nitrate, 3.4 milligrams per liter, higher than the spring's 0.8. Lead, 0.008 milligrams per liter at the tap, higher than the spring's less than 0.001, because Franklin's distribution system included older pipes with lead solder joints. Total trihalomethanes, 42 micrograms per liter. Disinfection byproducts created by the chlorine reacting with organic matter in the source water. The spring had 0 THMs because it used no chlorine. Total dissolved solids, 287 milligrams per liter, twice the spring's 142. On every measurable parameter, the Harmon Spring outperformed the Franklin Municipal Water System. The spring had lower nitrates, lower lead, lower TDS, 0 disinfection byproducts, and 0 coliform. Achieved without chlorine, without treatment, without pumps, without infrastructure, without annual operating costs. The mountain did the treatment. The rock did the filtration. The time did the disinfection. And the result was water that was cleaner than what 2,400 residents of Franklin were paying $45 per month to receive. Everett drove to the county health department with the lab report and the city water comparison. He sat down across from Dennis Rex Road and laid both documents on the desk. "Dennis, here's the lab analysis of my spring water. Full EPA primary standard, 87 parameters. Every one is below the maximum contaminant level. Most are below detection limits. Here's the Franklin City Water Report. On every parameter, my spring is cleaner. My spring has lower nitrates, lower lead, lower TDS, and zero disinfection byproducts. My spring produces water that's cleaner than what the city sells for $45 a month. The water quality is not the issue. The system compliance is supposed to protect the water quality. That's why the code exists, to ensure that private water systems produce safe water. My system produces the safest water in the county without the components your code requires. The code requires a drilled well because drilled wells are assumed to produce safer water than springs. My data shows the opposite. My spring produces safer water than any drilled well in Pendleton County that I've ever seen tested. The code doesn't have a provision for Mount Coco. The code doesn't have a provision for a water source that works better than the code's standard. The code assumes that a sealed well casing protects water quality. My 600 feet of sandstone filtration protects water quality better than any well casing ever built. The code assumes that a sanitary well cap prevents contamination. My spring emerges from solid rock on an uninhabited ridgeline. There's nothing to contaminate it. The code assumes that mechanical systems are necessary. My system is geological. The mountain is the treatment plant, and it's been operating for 110 years without a failure, without a chemical, and without a service call. If you're enjoying this story, consider subscribing to The Average Farmer. We share stories like this every week. Dennis looked at the lab report. He looked at the city water comparison. He was a conscientious inspector. He enforced the code because the code was designed to protect public health. And in most cases, the code worked. Drilled wells with sealed casings were safer than unprotected springs. Springs that seeped from shallow soil, springs that collected surface runoff, springs that had no filtration path and no residence time. Those springs were contamination risks. The code was right to reject them, but the Harmon Spring wasn't an unprotected surface seep. It was a deep rock discharge from a protected formation with 600 feet of natural filtration and 18 months of residence time. It was, by the lab data, the equivalent of a municipal water treatment plant built by geology instead of engineering, and it outperformed the municipality on every metric. The code doesn't distinguish between a surface seep and a deep rock spring, Dennis said. That's the problem with the code. A surface seep is a contamination risk. A deep rock spring with 600 feet of sandstone filtration is a treatment system. The code treats both the same because the code was written by people who didn't understand the difference. My grandfather understood the difference in 1891. My father proved it with a dye trace in 1968. The lab proved it last week. The mountain has been proving it for 110 years. I can't approve the spring as is. The code requires you to condemn the cleanest water in the county and replace it with a $10,000 drilled well that will produce water with higher nitrates, higher TDS, and a shorter filtration path. You're asking me to spend $10,000 to make my water worse. Dennis sat back in his chair. He was a bureaucrat, caught between a code that didn't fit and data that contradicted the code's assumptions. The code was designed for the general case, the average spring, which was a risk. The Harmon Spring was not the average spring. It was an exceptional geological filtration system that produced water quality results that the code's own standards couldn't match. Let me tell you about the variance, because the fight between the spring and the code took 6 months to resolve and required a process that nobody in Pendleton County had ever used: a public health variance for a private water system based on documented water quality performance. Everett applied for the variance in April of 2001. The application required a hydrogeological assessment of the spring's source protection, the dye trace data from 1968, supplemented by a new assessment from a licensed hydrogeologist, quarterly water quality testing for 1 year, 4 rounds of the full EPA primary standard at Everett's expense, approximately $600 per round, and a public hearing before the County Health Board. Everett hired the hydrogeologist, Dr. James Kessler from West Virginia University's Geology Department. Dr. Kessler spent 2 days on the mountain, mapped the spring's recharge area, confirmed the sandstone filtration path, and wrote a report concluding that the Harmon Spring represents a Class 1 groundwater source with inherent multi-barrier protection, equivalent to or exceeding the protection provided by a standard drilled well with sealed casing in the same hydrogeological setting. The quarterly testing confirmed what the initial lab report had shown: 4 rounds of testing over 12 months, all parameters below MCLs, all coliform absent, all E. coli absent. The water quality was not variable. It was consistent. The 18-month residence time buffered the system against seasonal changes in surface conditions: rain, drought, snowmelt, freeze-thaw. None of it affected the spring's output, because the water emerging from the spring had entered the system a 1.5 years earlier and had been filtered and purified over that entire transit. The public hearing was held in September of 2001. Everett presented the lab data, 4 quarters of clean results, the hydrogeological report, 600 feet of natural filtration, 18-month residence time, Class 1 source protection. The dye trace evidence, confirmed flow path, and the comparison to Franklin City water, spring cleaner on every parameter. Dennis Rexroad presented the code. Springs are not approved sources. The code requires drilled wells. The inspection found non-compliance. The health board, 5 members, 3 of whom were farmers who drunk spring water their entire lives, voted 4-1 to grant the variance. The variance was the first of its kind in Pendleton County, a legal recognition that a natural spring could serve as a private water source if the water quality was documented, the source protection was verified, and the system was maintained to prevent surface water intrusion. The conditions of the variance: annual water quality testing, Everett's expense, approximately $200 per year for a reduced panel; maintenance of the spring box cap and screen; quarterly visual inspections documented with photographs, and a 30-year review period, after which the variance would be reconsidered. Everett accepted. The spring was approved. The property transfer went through. Nathan bought the farm. The water from the 1891 spring continues to flow to the Harmon farmhouse at 2 gallons per minute, 52 degrees, clear and cold, filtered by 600 feet of Devonian sandstone, purified by 18 months of underground residence, and tested annually to confirm what the mountain has been confirming for over a century: the water is clean. That moment changed everything about how Pendleton County evaluated private water systems. And Dennis Rexroad, who'd enforced the code because it was his job, learned that the code was a floor, not a ceiling. and that nature had built water systems that exceeded the ceiling before the floor was even drawn. Let me tell you about the JD dealer, because the equipment angle in this story isn't a tractor. It's a well drilling rig. And the dealer who sold farm equipment had an opinion about a farmer who wouldn't drill a well. Travis Moyers ran the John Deere franchise in Franklin. He didn't sell well drilling equipment, but he knew the well driller, a contractor named Pete Simmons, who drilled most of the wells in Pendleton County, and who'd quoted Everett $8,500 for a 300-foot well. Travis had referred Pete to Everett, expecting the sale, expecting the drill rig on the mountain, expecting the $8,500 to flow from the farmer to the driller the way money flows in rural infrastructure. Quietly, inevitably, because the code required it. When the variance was approved and the well wasn't drilled, Travis mentioned it at the diner the way dealers mention things, with the tone of a man who lost a referral commission he'd been counting on. Everett Harmon got a variance on his spring. No well. The county approved a 110-year-old spring over a drilled well because the lab tests came back clean. The spring tested cleaner than city water? Cleaner than city water. Cleaner than any well Pete's drilled in the county. Cleaner than anything the health code was designed to protect. The mountain filters the water through 600 feet of sandstone. The water comes out cleaner than a treatment plant can make it. Travis drove to the Harmon farm, not to sell anything, but because the story had gotten under his skin, the way good stories do. He found Everett at the spring box, replacing the screen on the overflow. Annual maintenance, 15 minutes of work, a $4 stainless steel screen from the hardware store. Everett: Travis, you beat the health code with a water test. I beat the health code with data. The water test was the data. The hydrogeological report was the data. The dye trace was the data. The 110-year operating history was the data. The code is a set of rules written by people who assume that nature can't do what their rules require. My spring proves nature can do it better. No chlorine, no pumps, no electricity, no operating cost, no service contracts, no replacement parts. The mountain has been filtering water since the Devonian period. 380 million years. The health code has been filtering water since 1972. I'll take the mountain's track record over the codes. I sell equipment, Everett. Tractors, implements, machines that do work. Your spring is a machine, a natural filtration machine, built by 380 million years of geology. And it outperforms every machine the industry has built to do the same job. Because the industry's machines fight nature. My spring is nature. The industry pumps water through sand filters and chemical treatment because they start with contaminated surface water and have to clean it. I start with water that's already been cleaned by 600 feet of sandstone and 18 months of underground travel. My source is pre-treated. Their source is raw. The difference is where you start, not what you add. Let me tell you about the county-wide impact, because the Harmon variance opened a door that 2 other spring owners in Pendleton County walked through within 3 years. In 2003, a family on South Branch Mountain applied for a spring variance using the same process Everett had pioneered: hydrogeological assessment, quarterly testing, public hearing. Their spring, a limestone discharge at 2,600 feet elevation, tested clean on all parameters. The variance was approved. In 2004, a family on Spruce Knob applied. Their spring, a sandstone discharge similar to the Harmon Spring, but at a higher elevation. Also tested clean, approved. By 2006, 5 spring variances had been granted in Pendleton County. 5 families kept their ancestral springs instead of drilling wells. 5 springs that had been providing clean water for decades, in one case for over a century, were formally recognized as compliant private water sources based on documented performance rather than code compliance. The total cost of the 5 variance processes: hydrogeological assessments, lab testing, public hearings, approximately $14,000 combined. The total cost of drilling 5 wells to replace the springs, approximately $42,000. The variance process saved 5 families $28,000 and preserved 5 natural water systems that were outperforming the mechanical alternatives the code required. Dennis Rexroad revised his inspection approach after the Harmon case. He didn't stop enforcing the code. Surface seeps and unprotected springs were still risks, and the code was right to flag them, but he added a step to his inspection process. When he encountered a deep rock spring with apparent source protection, he recommended water quality testing before condemning the system. If the testing showed the spring met EPA standards, he recommended the variance process instead of automatic condemnation. Everett taught me that the code is a tool, not a truth, Dennis told a health inspector training session in 2005. The code protects water quality by requiring specific system components, but the code doesn't measure water quality. The lab measures water quality. When the lab says the water's clean and the code says the system is non-compliant, the question is, which one matters more? The answer should always be the water, because the water is what people drink, not the code. Let me tell you how this ends. Everett Harmon passed the farm to Nathan in 2001. The property transfer that triggered the inspection that started this story. Everett continued living on the farm until 2010, when he moved to assisted living in Franklin at 83. He drank the spring water every day until he left. Nathan drinks it now. His children drink it. The water tastes the same as it tasted in 1891, when Jasper Harmon dug into the mountainside and found a sandstone fracture flowing cold and clear. The spring continues to flow at 2 gallons per minute. The annual water test continues to show results below EPA limits on every parameter. The $4 screen on the overflow gets replaced every year. The spring box cap, poured by Willis Harmon in 1952, is sound. The polyethylene pipe, installed in 1978, shows no degradation. The system's total annual maintenance cost, approximately $204. The $200 water test plus the $4 screen, the Farmall 560, is in the barn. Nathan uses it for hay work and for hauling supplies to the spring box when the annual maintenance is due. The road to the spring box is a quarter-mile farm lane that climbs the mountainside through hardwood forest. The same lane that Jasper walked in 1891, that Willis drove in 1952, that Everett maintained for 50 years. The lane is steep, rough, and beautiful in every season: spring wildflowers, summer shade, fall color, winter silence. The spring box sits on the mountainside at 3,200 feet. The sandstone walls gray with age, the concrete cap green with moss, the overflow trickling into a small stream that feeds a patch of watercress that Everett planted in 1974 and that Nathan harvests every April. The watercress grows because the water is clean enough to grow in. The watercress is the spring's quality report, a living indicator that the water is pure, cold, and fit for the most sensitive plant in the Appalachian Highlands. If this story stayed with you, subscribe to The Average Farmer for more. We'll see you in the next one. The county measured the code. The farmer measured the water. The code said the spring failed. The water said the spring was the cleanest source in the county. One of them was wrong. 110 years, 0 illness, 0 coliform, 0 lead, 0 chemicals, 0 operating cost. 600 feet of sandstone. 18 months of residence time. A $4 screen and a $200 test, and a mountain that's been filtering water since the Devonian period. Because the code measures the system. The lab measures the water, and the water is what matters. The system is just the code's guess about how to get clean water. The mountain's method, rock, time, and gravity, is older than the guess, cheaper than the guess, and cleaner than the guess by every measure that matters. The inspector had a checklist, the farmer had a mountain, and the mountain won.